Okay, this is review for our lab final, which will be next week, the same time, for 2.5 hours. So you will have 20 questions, and those 20 questions are multiple choices. So the first topic here, and I just put for you all the topics here in the PDF, will be significant figure. So the first topic is, so let me write here. Um, this is lab final exam. So the first topic is sig figs. Well, you can't expect this one here to be asked in the lecture as well in the final ACS exam. So, and I'm just want to show you here. This is the sig figs uh, stuff here, and then what I will do, I'll take a snapshot of this, and then we can have uh, we can answer those questions here. Let me take this one here and just a review here, and then okay, so here it is. Now let me just paste this one here, and okay, so let's answer these questions. What are the sig figs on these figures here? So the first one, how many we have here sig figs? Okay, correct. This is 5. Next, 6. Next, no, not 2. Look at this is a decimal here. 1003. 100 decimal 3, that's 4. How about the other one? How about this one here? 4, 1 decimal 008, that's 4. The zeros are trapped between 1 and 8. Whole number, they are significant. How about following one? 3. The last 0 is satisfying the both conditions happening at the same time. The presence of the decimal as well as they come after whole numbers, number 4. So how about the next one? Correct. How about this one here? 1, correct. How about here? 1, no decimal, correct. How about here? 6, okay. How about here? There is a decimal. Presence of the decimal is there, satisfying the first condition. The second condition, they come after whole number. 1 is there. So how many is this? 5. And how many the other one? There is no decimal. However, those zeros trapped between what? Two whole numbers. This is what? 6. So that's the first topic. We can go further and look at addition of the of those sig figs. And I would like maybe just hold on, take this one here out. Just one, and then you tell me, and then we'll take one from here and then copy it here So taking this one here. Now we'll do some, this one is done already. So we can take this one here out. Now we want to see what's the answer for this. What's the answer of this addition or subtraction? We are just an example of, we are still in the sig fix. What's the answer here? Somebody has it? I can help you here a little bit. I will do the calculation. Don't worry. This is 5, 6, 7 plus 103, 5.0 plus 1.4567. So the answer is, I can't even copy and paste this one here. The answer is this one here. This is the answer. Can write it here. This is our answer. So make it bigger here a little bit. Hold on. Make it bigger so you can see it. Our answer is correct. So the answer is correct. No, that's not the final answer. That's whatever is coming from the calculator. So this is coming from the calculator. We did not do this one here. This is coming from, this one here is from calculator. So now the rule is that when you subtract or add, is different from the multiplication and division. You deal with the significant figure. Least significant figure will control the outcome of rounding off. But however, when you add or subtract, the digits after the decimal will control of the rounding off, the least digit. So here we have how many digits after the decimal? 3 digits, correct? Here how many? 1 digit. And here how many? 4 digits. So the winner is, this is 4 here. This is, will control the answer. So the answer is 169.0. Now, just, I did not put this one here in the final, but I don't know if the ACS is covering. But suppose now we have, I want to add this one here and then say plus 13. So you'll tell me this, the answer is from the calculator is 278, correct? 1. But that's not the final answer. That's just from the calculator. However, here we have 1 digit, correct? And here how many we have? 0 digits. What's the least is? 0 digits or 1 digit? 0 digits. So the answer is here. Answer is 182. No decimal. So here it is. No decimal. What do you mean? If I put the decimal here, suppose I put the decimal here, that does not really matter because you are looking at the digits after the decimal. So how many digits? The decimal is there, or without it, if it's present or non-present. But how many digits after the decimal we are looking for? So 0 digit. There's no digits. It has a decimal, yes, but it does not have the digits. So the answer will be the least digit, which is 0 digit. So that's, yeah, no decimal, no digits. So no digits. So going to the next topic. The next topic will be this sig fix. I can take it out. I want to make a mistake, but the density. The next topic is density, correct? And the density, as you can see, the density is, as you can see here, is the ratio between mass over volume. Mass over volume. That's the density here. It's a ratio. Mass over the volume. So now they give you an example here, sample example, and then the density. What's the density of a pillared ball that has a volume of this? Remember the centimeter cube. So here it is. Let's write it here. 1 cc, which is 1 centimeter cube, cubic centimeter, 1 cubic centimeter, correct? 1 cubic This is really is 1 mil by definition, 1 mil. So we have to know this, especially we are working in the lab. That's 1 cc. Cc is a unit mostly used for cubic for the volume, but this is used in the hospital a lot. So how many cc's is the doctor is giving his or her patient? So cc's means cubic centimeter, which is a volume, unit of a volume, which is really 1 mil. Now suppose we are missing a graduate cylinder to measure the 1 mil. So, and this is, then we'll have in our approximation here, you will see it, that's 1 cc, 1 cubic centimeter, 1 cc, 1 cubic centimeter is 1 mil. That's absolute value by definition. And this one here is equal 20 drops. Equal what? 20 drops by the pipe, by the pipette. This plastic pipette, disposable plastic pipettes or eyedropper. Correct. So that's we have to know. It's not part of the final exam, but at least we have to know it. So now you tell me. Take this one out, and then I want to see if we can determine the type of. You have this, okay? The recording will have all this information you have. Let me here go down and then determine from the table we have what is what is the block of stellar. Okay, yeah. So we are calculating the volume here, the mass here, and then we are going back to look into the table what this compound is. Again, it's gram per centimeter cube or gram per mil. For solids, always gram per centimeter cubes. For liquids, gram per milliliter mil. For gases, gram per liter. So that's the 3 units different. Gases, gram per liter. Okay. For liquids, gram per milliliter. For solids, gram per cubic centimeter. Okay, so those are the units. So I'm gonna see if we can look at those here. We can pick up any one of those. I don't know, and the decimal we have to watch for the decimal here. Let's take the one is critical with the decimal. So 680 and 1000. The volume is 1000 centimeter cube. That's those all solids, and the mass is 680. So the density will be. Let's look at the density here. density is mass 680 divided by 1000. Now, your intuition will tell you that maybe this is one sig fix, okay, and this is two sig fix, and your answer has to be one sig fix. Well, in the reality, we should really put the decimal in front or at the beginning or the end, because 1000 it looks like an exact absolute value. But if we go, but whatever they have no decimal, our answer, how many sig fix will have? No. If you say just because this decimal is missing here, so say 1. So this one will be, how much is it? 0.680 gram per centimeter cube. And since we have one sig fix, will be what? 0.7, correct? Gram per centimeter cube. Well, 0.7, we can go and look what type of material we are dealing with, okay? So let me see if we can get 0.7. 0.7 is nothing. Yeah, 0.6, 0.9. The only thing is very close to this value is, somebody will tell me what that really is? It's gasoline, correct? Gasoline. That's what we got. So the material here is gasoline. Now remember, that's the density. Since the density is mass over volume, sometimes in the exam they don't ask you direct to the density, but they ask you for the mass. So out of this here, you can make mass equal density multiplied by volume, or you can make the volume is mass over over density, correct? So those are two types. Those are two sub-formulas from the main. This is the main formula, so we have to write for the main formula. So this is the density question, and I did put for you one single question. That's very straightforward, how to calculate this. So we calculate it, and now we have an example of this, how to determine the type of the material we are dealing with. So let me take this one out, and as I said, the recording, you have it. You can go and review it, and let's go further here. The next is, which is very challenging, is Lewis dot structure and the whisper. We have to know the molecular shape and the Lewis dot structure. So you can pick up any of those and tell me what you think, or we can take those four, okay? So sulfur, as what is the total? We'll first calculate total of the VEs, valence electrons. Total VEs. VEs stands for valence electrons. So how many we have? Sulfur 6, group 6A or 16. So 6, and hydrogen group 1. So 2 of hydrogen. So we have 8 valence electrons, VEs, 8 VEs. That's the total. How many total here we have? Oxygen is 6A or 16, sulfur 16, that's 4. 4 multiplied by 6, not 16. 6 multiplied by 4, this is 6. Those are, this is 6 and this is 6. So 4 multiplied by 6, 24 VEs. And here we have carbon has 4, hydrogen has 2, bromine is 7A or 17, plus 2 multiplied by 7, correct? So you have, those are valence electrons. We are looking at the valence, the outermost shell, correct? So 4, and this is 14. 14 and 2, 16. How many we have? 20. Okay. So this one is 1. Carbon is 4. Nitrogen is how many nitrogen? 5. So this one is 10. These. Yes. No, not 16. 1, 6. No, don't mess up the atomic number with the valence electron number. Valence electron number is number of the group. So the VE, valence electron, equal to number of the group. The atomic number then, atomic number is totally different. Atomic number is equal number of the protons or number of electrons, correct? Either or, in the neutral atom. Yeah, that's totally different. Yeah, different from VE. VE is the number of the group. Okay, guys. Now we know the valence electrons. We know the total. So let's do that structure and then determine the whisper out of this. I mean the molecular shape. We'll not do electron shape. We'll do the molecular shape. Okay. So taking this one out, and as I said, it's in the recording. You can play the recording as much as you can. So here it is. I'll take this one here out. Now hydrogen, we know the first one. Let's take the first one. Just switch color. So hydrogen always at the edge because it has one valence electron. It cannot be in the middle. It's not connected to two valence electrons. It has only one. So this one here, we'll put the sulfur in the middle. Hydrogen is here. That's the hydrogen one. That's connected single bond with the hydrogen. Single bond with the hydrogen here. Then we know the sulfur is in 6A. It has to have how many? 6. We used one here for the first single bond. We use the second one for the second single bond. Then we have 4 sets. So those 4 sets will be not bound to nothing. So there will be lone pair, 2 lone pairs. So if you recall, from whatever we said, the whisper code, this is this will be, just you tell me, this is A. This is the heart and the core of the molecule. That's the central atom. This is a terminal. This is a terminal, and this is lone pair, and this is another lone pair. A is the central atom. So this is A, B2, 2 terminals, and 2 lone pairs. So, and you recall this one here. Those are 4 zones, correct? We have 4 zones. 4 units, 4 regions, 2 single bond and 2 lone pairs. Yes. Yeah. No, one. This. So the best thing is to do this one here. So 6 means those are the 6. This is the one for hydrogen. This is the one for hydrogen. Which one? This one is 1 dot. Yeah, this one is just 1 dot here. Which one? Yes, that's one here from hydrogen. They're sharing. Those are covalent bond. They are sharing a covalent bond. Is a bond shared by valence electrons. Can be single, can be triple, doubles, can be triple. So this is a single bond shared. One valence electron from sulfur, the second one from hydrogen. Okay, guys? Yeah, that's a bond. you have to be shared for not from the same from the same element. No, different two elements will make a bond. Correct. Sometimes the same elements, but that's if you have like hydrogen here, hydrogen and hydrogen, but still two atoms you have. This is hydrogen. So if I have AB2E2, those are four regions, 4 units, because you have two sets of lone pair and two sets of single bonds, correct? So if you look at this, this will be bent, correct? That's the molecular shape, will be bent. But we are not going to electronic shape. Electronic shape, it has 4 zones. We have to consider each lone pair. That will be tetrahedral. But we are not interested. We are interested in the molecular shape, which is bent. Okay, guys, this is bent. Now, let's take the second one. The second one, it's already for us in the question, underline the central atom. Look at the central atoms underlined. Here is S, and here is given to us carbon is the central atom. It has 4, 1, 2, 3, 4. And then you have bromine, has 7 bromine, so 2, here's 1 already, 2, 3, 4, 5, 6, 7. And bromine here, that's 1 here, 5, 6, 7. And then you have here hydrogen, and here you have hydrogen. Okay, so according to what I can see here, I say, well, this is A, B, 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 and B. This is AB4. There is no lone pair here. Okay, there is no lone pair. AB4 means what? A tetrahedron. AB4 is tetrahedron. That's AB4, no lone pair. Correct? That will be tetrahedron. The above one looks, it was like tetrahedron, I mean, to begin with, from electronic shape point of view, but since we are not consider this, we are considering the molecular shape, eliminating those lone pair effect, so that will be pent, correct? That will be pent. So this is 2, and I will take number 3, C and D. We'll take C and D. So as I said, this will come already. You can watch the recording here. So it is. Let's take C. So you have S, and then S is the least electronegative. Always tend to be in the central atom. The most electronegative are terminals. So I will say, well, we have 3 of those. So if oxygen always has to obey octet rule, sulfur can violate octet rule. That's fine. So then I would say I have this. My intuition will tell me oxygen always like to be double bond. Remember, this is here. Those are the 6 for this for oxygen, and those here 2, 2, 2, 2, 4, and then so that satisfies this. Sulfur is 6, and you can even visualize the 6 of sulfur here. Say okay, those are the ones 6. This one is 6. This one is 6. This one is 6. And let me just go here and say okay. Here, those 1 here, 1 here. So Okay, that's the correct. This is the correct that Lewis dot structure. Okay, so we have three sets of three regions correct, and we have three units, three regions, whatever you call them, uh, because that three double bonds. We don't differentiate in double bond, three bond, triple bond, or lone pair, so or single bond. So three regions or three zones or three units, and then we have to label this. As I said, central atom is underneath for us. This is A, this is B, this is B, this is B. There is no lone pair on the central atom, so this will come as AB3. Molecular shape will be trigonal planar. Okay, trigonal planar. Yes. Which one? Remember, you have four elements. You have to look into those four elements. They have to obey octet rule. All the other elements, they can violate. Those the ones they cannot, by all means, carbon, nitrogen, oxygen, fluorine. You'll not find this one here in the textbook, in any textbook, as a matter of fact. But it's coming from the experience. When you draw a lot of Lewis dot structure, you will see carbon, nitrogen, oxygen, and fluorine. It's a must. They have to obey octet rule. Sulfur is not, correct? Now look at the octet rule here. The oxygen, all the oxygen is 8. 1, 2, 3, 4, 5, 6, 7, 8. When you look at the octet rule, you look at the valence electrons, shared or non-shared. We have two non-shared sets and two sets of shared. I mean, three sets of shared, but one is made here for, you can calculate all those here. So all oxygen is 8. So oxygen is a satisfying octet rule. And if you look at the sulfur here, sulfur is, if you look at the sulfur here, you'll be surprised. The small is violating the octet rule. And if I put this one here, green, I have for sulfur now. 1, 2, 3, 4. Those are shared, correct? 5, 6, 7, 8, 9, 10, 11, 12. So you will see sulfur has 12 shared and non-shared, I mean, total shared electrons 12. That's not octet rule. So sulfur is not obeying octet rule. And we don't really care that much about sulfur. It can evaluate the octet rule. However, if we have those four, carbon, nitrogen, oxygen, fluorine, then we have to watch for the octet rule. Okay, guys? So we have to, I mean, you can try and error by making first single bond. But remember, oxygen loves to form a double bond. Nitrogen loves to form triple bond. That's always the rule. Nitrogen loves to have triple bond. Oxygen loves to have single bond. However, carbon has no preference. Sometimes a single bond, sometimes double bond, sometimes triple bond. Correct? So no preference for carbon, but oxygen most of the time is preferred to be in double bond. Does oxygen have a single bond? Yes, it does. Does nitrogen have the single bond? Yes. But that's the general trend for the bonding of oxygen to be double bond and nitrogen triple bond. And that's what I will do it for the next one. That's what I will do for the next one. I have nitrogen, correct? So my intuition would tell me to satisfy the octet rule for nitrogen. Most probably nitrogen will be satisfied with the octet rule to be in the triple bond, correct? Here oxygen is satisfying the octet rule. It has, I mean, my intuition would tell me it has to be a double bond to satisfy the octet rule. Yes. Yes. And the shape, yeah, I gave a small tiny in the I college, I gave a small tiny table. Not all of it, just small tiny, about 4 or 5 AB2, AB3, AB4, then AB2, E1, AB2, A3, AB, AB2, E2. That's about then, and then we did AP3, E1, about 6. You have to memorize only 6. Those in the table I gave. The periodic table is given to you, and looks like the printing was not good. Very. I might just print one at home, or print maybe before the exam, or just put on the periodic table here on the screen. Yeah. Yes. Well, the degrees I did not ask this time, but in the lecture they might ask. Yes. The triangle, the trigonal planar. What is this? This is 120 degrees. The tetrahedral 109. Yeah, tetrahedral 109.5 degrees. Linear will be 180 degrees. And I did not. This is not in the scope of the lab, because we did not cover it all. But in the lecture, it might be there. They ask you about the angle. Will ask you is polar or non-polar. No, the pent is less than 120. So it can't be less than 100. I mean, it depends how many zone you have. If you have pent like looking like um, this is pent, correct? So this is pent. But you have 4 zones, correct? The 4 zones is 109 tetrahedral electronic. But since you have pent here, the pent is 109. So that will be reduced a little bit from 109. Are you following me here? So it will be around 105. And if it has, like ammonia has one lone pair, H8, it's still 4 zone. That's tetrahedral from electronic shape point of view, correct? However, if you look like this, it has one lone pair. It goes 107. So it looks like each lone pair will eat up 2 sets. I mean 2 bells, 2 electron pairs. So one lone pair without lone pair is 109, correct? Lone pair only one, it shrink further 2 degrees, so 107. H2O, 2 of them, so 105 will be going from 107, 2 units down, 107. So if you have an 4, then you can expect there will be what? 103. So it looks like as there is a trend somehow. There is a trend, but this very rare you see an element with 4. Then you have a complex molecular structure. So it can be linear and trigonal planar. Okay, so it can have two shapes in one. Okay, guys. So yeah, and then you have the polarity. We did not discuss the polarity. That's beyond the scope of the lab, but in the lecture we did cover it. So if I look at this, is this polar or non-polar? Non-polar. Why? The answer is correct. It's non-polar. Correct. All the terminals are the same. It will be polar if I put this one here, change it with sulfur. Then yes, 1 sulfur 2 oxygen, that's polar. But if they are the same, they are non-polar. How about this one here? This is polar, non-polar. HH. This is polar, non-polar. This is polar. Although we have the same identical terminal atoms, but we have lone pair. So anytime I have a lone pair, the molecule has to be polar, regardless. So you don't have to look it up or something. The presence of lone pair will enforce the polarity of a molecule. Ammonia has 1 lone pair, it's polar. The larger the amount of lone pairs you have with the molecule, the higher the polarity. So which is more polar, nitrogen or H2O? I mean ammonia or H2O? H2O, it has 2 lone pair cells, more polar than than the one here, correct? But that's beyond the scope of the lab final exam. That's covered in the lecture. And the SS exam, I think, will cover some of those. So let's look at the last one. I have to, as I said, we have how many we said? We have to really take care of them. Carbon, nitrogen, CNOF. Remember the CNOF here? CNOF, carbon, nitrogen, oxygen, fluorine. Those are the four elements I have to really to pay attention for their octet rule. All the other elements, I really don't care. Hydrogen always terminal. Okay, so that's the way it is. So now, this one here, carbon says in the middle, correct? So carbon is here, hydrogen is here. Now I have to obey I have to follow the octet rule for carbon and nitrogen. This is carbon and nitrogen. So, and I know from my experience, nitrogen tend to have a triple, correct? So that's now everybody's happy with A. Nitrogen has one. Let me see the octet rule here. 1, 2, 3, 4, 5, 6, 7, 8. Shared or non-shared, the total, 8. That's nitrogen is good. Carbon is 6 here, this 6, correct? 7 and 8. And hydrogen always terminal, correct? So this one here, then I have A, B, B. So this is A, B2. What will be? Linear, and the angle is 180 degrees. Now, it is polar or non-polar? Well, this one here, I have, there is no lone pair. I say, okay, polar, non-polar. There is not identical. I have to go and look at the table of electronegativity. So electronegativity between this and this is 3.1 and this is 2.1 and this is 2 point something, I don't know, but you can look 2.1 is 2.5 or something. So you will see the polarity is still there. So this one, there is a difference here, polar covalent. So that's polar. You'll see the total here. If you look, this one will be maybe 0.5, 1 point. This is, I think it's 0.5. This direction, nitrogen is more polar than carbon, and this is maybe 0.4. Okay, so or less, I don't know. So 0.4 is non-polar. 0.4, you know the table. I don't know the electronegativity exact number for all those, but at least you get the idea. Yes, but that's beyond the scope of the lab. We did not cover this one here in the lab. Did we cover electronegativity in the lab? No. But therefore, in the lecture, there will be a question in the lecture. Yes, they will give you the table. You don't have to memorize numbers. But you have to know the table of the range from 0 to 0.4, the electronegativity difference. Electronegativity difference here. So from 0 to 1.4, this is covalent nonpolar. Covalent nonpolar. Then you have greater than 0.4 to 1.8 or 1.9. This is covalent greater here. So this is covalent polar. This is covalent polar. Then greater than 1.8, in textbook 1.9, this will be ionic. So that tables here, you should know. That's in the lecture. That's nothing inside the lab. That's not exam. Will be shown in the lab because we did not cover this one here in the lab. So I think that will be it, and I'm going to have, as I said, this one will the recording will be there, and then you can look into the whole thing. So the next topic is balancing chemical equation. Balancing chemical equation. So you tell me which one you like, and then I'll take a snapshot of this, and you tell me. Number 6 and 9, maybe here I will take. I like to see the 818 because that's challenging one. I did not put something like this, but it might appear inside. Okay, so let's take those quick, and then we'll see how we so let's look at this. Okay, so now the first one is straightforward, correct? Your intuition will tell you this number. We are looking at number 7 here. Number 7. Number 7 is I have CH4 methane plus oxygen give us CO2 plus H2O. So since carbon is 1 here, 1 is, I'll leave it as is 1. I don't do anything for it, correct? Hydrogen is 4, then I'll put 2 here to make hydrogen 4. However, by doing this, I have oxygen is here 2. Oxygen is here is 2. 2 plus 2, oxygen is 4. And here is 2, so I have to put 2 here. Correct? Now I have 4 oxygens, 4 hydrogen, and 1 carbon. Is this correct? Yes. So then I will say the mole ratio is the mole ratio or coefficient ratio, mole ratio, or we call it sometimes coefficient ratio is 1 to 2 to 1 to 2. So 1 to 2 to 1 to 2. Did I put something like this? Yes. I'm putting some question like this, and you have to tell me multiple choices. Which multiple choice is correct? Similar to that. So this is number 7. So this is the balanced chemical equation is with the ratio between the products and reactants 1 to 2 to 1 to 2. Okay, guys. So let's take the number 8. Okay, let's take number 8. Any question you have? Any question? Just let me know. Any question? No question? Straightforward? Okay, so let's take number 8. Number 8 is C3H8 plus oxygen, CO2 plus H2O. Well, I have 3 carbons here, correct? So how about putting 3 here? I have 8 here hydrogen. How about putting 4? Now this will take care of carbon and hydrogen. However, then this will destroy the balancing of oxygen, correct? That will destroy the balancing of oxygen. Well, let's look at this. Carbon and hydrogen, we know now will be balanced. But here, 3 multiplied by 2, oxygen is 6. 4 multiplied by 1, understood nitrogen is 4. So this one here is 10 oxygens. Here is 2. So I have to put what here? 5, correct? So the mole ratio, so our coefficient ratio is 1 to 5 to 3 to 4. So this is 1 to 5 to 3 to 4. This is the mole ratio or coefficient ratio, correct? So I'm not writing it, but you get mole ratio and ratio here. Okay, guys, let's take number 9. Yeah. First, what's that? the 5. 3 multiplied by 2 is 6. 4 multiplied by 1 is 4. 6 plus 4 makes 10. And here is 2, so put 5 in there. Make sense? Oh, okay. That's gonna happen. That's gonna happen. Don't worry. So, as I said, that will be recorded, and you can look into the whole thing. So, number 9. Number 9. So, I give you balance equation, one question, and then the other one is more ratio. So, 2 questions of this in the final. So, let's do 9. C8 H18 plus O2 give you CO2 plus H2O. So now you tell me what you have to do here. I've just, every time I start the whole thing by myself, I need help here. What should I do here? Somebody tell me. Put 8 here. Perfect. That will take care of carbon. And hydrogen, what should I put? 9, 18. But by doing this, I'm destroying what? The oxygen. So now this one is 16. This one is 9. So this is 25. Now, you will see if the oxygen is the amount of oxygen here is 2, correct? And this one 25. Whenever you get even odd number, this is an even number. This is an odd number. So then you have to go through what? Fraction. You have to go through fraction. That's general rule. You have to go through fraction. So if you have even, odd, odd, even, you have to go fraction. But if you have odd, odd, even, there's no fraction. So what you will do here, take the biggest one in the top, and the bottom is 2. Because 2 will cancel out with the 2, correct? But it's not canceling, but I'll show you. Now we have on both sides 25. Nature does not like fractional molecules or fractional atoms. It's not existent, correct? So in order to get around this, I will have to multiply the whole equation to get rid of this. This is 2. If it's 3, I will multiply it by 3. If it's 2, I will multiply it by, so by 2 here. Okay? 2 C8 H18. 2 multiplied by 25 over 2. The 2 cancels with the 2. That's 25 O2, correct? And this is 16. 2 multiplied by 2, 16 CO2 plus 18 HO. All this by 2. Now you tell me if it's correct. Carbon is 16 here, correct? 2 multiplied by 16. Carbon here is 16. So carbon correct, carbon is correct. Hydrogen is multiplied by 2, that's 36, correct? And hydrogen 18 multiplied by 2 is 36. So hydrogen is good. Let's look at oxygen. Here we have 25 multiplied by 2. This is how much? 50, correct? Now let's do this. 16 multiplied by 2, how much I have here? 32 oxygen plus 18 multiplied by 1, understood not written, is 18. 18 plus 32, how much is it? 50. This is the whole balance equation. Now, I'm interested in the more ratio, more or less, correct? So the ratio is 2 to 25 to 16 to 18. See how large the ratio is? And we can do the next one. It's easier one, but we can do them too. So let's see. Okay, guys, I'm taking this one out. Nobody has it? You can go to recording. You can find it in the recording. So now you tell me number 10 and number 11. Those are the simplest one. So you should have no problem with them. So what should I do in doing this? Well, the idea is if I have parentheses, it means I have groups. I'm not taking those groups apart. I'm taking a virtual, making a virtual here, parentheses. I have three of them here and one of them here. So I put three here. Why? I treat the OH as a group. I treat the, anytime I see a parentheses, that's a polyatomic group or ion. So I just take it as one unit. I put three because the three OH, three here. By doing this, correct guys? By doing this, I have taken care of the OH. Okay. However, I have here the chlorine is 3 and the sodium is 3, so I'll put 3 here. So that's taken, I have taken care of the sodium. Sodium is 3, OH is 3, 3 chlorine and 1 iron, and I think it's now balanced, correct? Is it balanced or not? Balanced. So the mole ratio is 1, understood not written, understood not written, 1 to 3 to 1 to 3. That's the mole ratio or the coefficient ratio. Okay, guys, so how about the next one? How about the next one? What should I do? What should I do? Look again. We are talking about, this is what? Even or odd? Even. This one is what? So we have to go through what? Fraction. Correct? We have to go through fraction. So if I will say this is the largest one, the largest always in the top, okay, over 2. Because the 2 here have to cancel with the 2 here. 5 over 2. So P plus 5 over 2 O2, and this is P2O5. Correct? And here it is 2. I put 2 here. It's balanced. It is balanced, but nature does not support fractional atoms or molecules. So then I have to put the whole thing multiplied by what? By the value here. Correct? So 2. Then I have 4P plus 2 multiplied by 5, 10 oxygen. 2 multiplied by this, 2 B2O5. So what's the mole ratio? 4 to 10 to 2. It's balanced? Balanced or not? So what we have here? 5 over 2. And this is 2, correct? 10. This is 4. And this is 4. It's not balanced, is it? Because the oxygen is, oh, I know that I made a mistake. You did not even tell me. Come on, guys. 2 multiplied by 5. The 2 cancels with the 2 out. Nobody is telling me so. Well, I thought I'm sleeping, but somebody else is sleeping, correct? 2 cancels out. Come on, guys. You know what the error is? There's no error, but we did not cancel the 2 with the 2 here. So that will be, okay, so that will be 5. Correct? Now we are talking. Correct? We did not cancel the 2 here with the outside 2. We just multiplied by 2. So I have to cancel the 2 here. So guys, this will cover this area here. And let me see what area we have. Balancing moles and molar mass. Okay, mole and molar mass. Okay. Molar mass. So let me take this one out. Take this one here out. Okay, guys. Let me look at the moles Okay, so we can look into this here. Uh, I mean, you know how to calculate moles and from moles to grams, grams to moles, correct? It says here how many moles are in 40.0 grams of H2O. It did not give you the formula, but you know H2O is H2O, two hydrogen, one oxygen. So how I approach this one here? How many moles in 40 grams H2O? So always start whatever is given to you. So it's given to me 40 here. Here's a fixed gram of H2O. Here number of moles. So what should I put here? I have to get rid of the grams here, gram of H2O, and I need the correct. I need to introduce the molar mass. So here it is, molar mass, correct? What's the molar mass of H2O? So this is 2 hydrogens plus this is 16. This is 18. So this is 18.0. Oops, not here. Sorry. 18, not moles, 18 grams. Sorry. So 18.0 gram per 1 mole H2O. So that will give us the grams cancels out, and 40.0 divided by 18.0, we can say this is 0. What? 0.45. 0.45. No, we need 3 sig figs, correct? So how much? 0.45 what? 0? 0. So then this is mole H2O. Okay, guys? That's, you don't get this? The answer, you mean? I will get 2, not this time, yeah. I agree. 40 divided by 18, it has to be 2. We're 36 and something. Yeah. So here it is. 40 here divided by 18. I'll take care of sig figs at the end. So this is 2 point, yeah, that's correct. So this 2 point, yeah, 2.22 more H2O. Okay, guys. Now this is H2O. We can take the second one. How many grams? The opposite. Number 2, how many grams? So 3 sig figs. So let's take the second one and calculate the grams out of the mole. So grams out of the mole. So here it is. I'm taking this one here. I'm calculating number of grams. Here it is, guys. So number of grams of Na2, this is sodium oxide, will be 2 steps, of course. So you start with the moles of 3.7 moles of Na2O, correct? And we have to use what? We need the number of grams. So we need the molar mass of sodium oxide. We have 2 sodiums and then 1 oxygen. This is 1 multiplied by 16. This is 2 multiplied by 23.0. So, and this is like this, 16 plus this is 6, 4.0, this is 16.0. So add them up, how much is it? 5 would be 6, correct? 6, 2, something like this. So therefore I put 62.0 gram Na2O. At the bottom is mole Na2O. The most cancels out. I have 62 multiplied by 3.7. How much is it? How much? 230. Okay. 230. And here's 3 sig fix. Here's 2 sig fix. And our answer is really is 2 sig fix because there's no decimal. This 0 is not count. So our answer is correct. So I think that's enough for this. And just looking at this here. We'll go for pH calculations. So let me take this one out. And we are going to the pH calculation. So, well, the pH calculation, we have to look at this. What is the pH of molarity of HCl is 0.0235. Well, the pH as we learned, if we call this one here, the pH is minus log H3O plus, the hydronium ion, correct? The hydronium ion coming from the HCl is minus log 0.0235. And this one here, how much is it? Give me all the answer here. How much is it? 1.6, 1.26, 1.2609, 29, 1.269. Okay, 629. Okay. So you tell me again. Again, that 1.6289. Okay, now, since we have 3 sig figs here, this is 3 sig figs. So our answer, the digits after the decimal has to correspond to 3 digits after the decimal. We have here 3 digits because it's really corresponding to how many sig figs you have. So we have 3 sig figs. We have to have 3 digits. So the answer is 1.629. So 3 digits. We have 3 digits here. 1.69. So let me just take this one here out. So 1.69. Now we'll have number 2 and 3. So this is of course acidic. HCl, hydrochloric acid, strong acid. So that's acidic, correct? So let's do this 2 and 3. Let's do 2 and 3. Okay. So what is the pOH of 0.023 molar HCl? Well, again, that's the same thing we did. The pOH minus log the OH, correct? And this is minus log. The concentration is 0.0235. And we say that is 1.629, correct? So we said this is 3 sig figs. 3 sig figs had to correspond to 3 digits. So 3 sig figs has to correspond to 3 digits. 1.629. Okay, guys? So that's the pOH. It has to be 3 sig figs. So let's do number 3. 3 digits, okay? So let's do number 3. As I said, that will be in your recording, so you can look at the recording, and I think it will be very good to review. So let me take this one here. I will do this one here, and then the fourth you can do it in your pace here. What is the pH of 6.0 10 to minus 3 molar KOH solution? So this is a basic solution. Concentration is of OH. Well, KOH is concentrated, so will be, and the pH is correct. Can we get the pH directly? No, because the pH is minus log H, but we have KOH here. So what I will do here, just simple one, I will say if I have the OH, then I will say the POH here. Minus log the OH. And minus log 6.50 10 minus 3. So how much is it? Log 6.50 10 minus 3. How much is it, guys? Point. Slowly. Hold on. 2.187 what? 7087. That's good because it has 3 sig figs. It has 3 sig figs. We have to respond this one here to 3 digits after the decimal. Okay, so that's the POH. But we did not solve the problem for the pH. However, the rule is pH plus the POH is 14.0, whatever is 14 here. We go back. So 14.0. So the pH will be 14 minus the POH. 14 minus 2.187. So how much is it, guys? 3, correct? 9 is 1. 9 is 8. And this is 13 is 11, correct? Am I correct? Yes. So, and then I have, because this is controlling. The beginning is controlling the outcome. So I have to have this 3 here. 3 digits because I have 3 significant figures. Regardless, I can put here whatever. I can put 3 zeros here. It does not matter. So you can put 3 zeros. But the main thing is your answer has to correspond to the beginning of the whole thing. Okay, guys? So, everybody's following? And I want you to memorize this. pH plus POH equal 14. So this one, whenever you have OH, you cannot determine the pH direct. So you first determine the POH, subtract it from 14, and watch out for the digits. Digits are 3 6 or 3 digits after the decimal. So, and we are going to have the next topic, titration. Titration here, titration, I'll take first one. So we have titration here. So titration, always remember that the molarity of unknown, you need 4 steps. 4 steps. So needed, here it is. 4 steps are needed beside the balanced chemical equation. The balanced okay, so those things you have to watch for them. So we don't know the equation. So we have sodium hydroxide and HCl. So sodium hydroxide, that's the balanced chemical equation, plus HCl. Base plus acid will give me salt. Double displacement, this will take the chlorine, NaCl, and the OH will take the H plus H2O. H2O is HOH. So that's balanced, and this is because it's 1 mole of sodium hydroxide base to 1 mole of hydrochloric acid. Okay, so 1 to 1 mole, which is very important. So if it takes 83 milliliter of 0.45 molar sodium hydroxide solution, that's what you read from the burette. You read 83 mL, for example. Okay, to neutralize 235 milliliter of an HCl solution. What is the concentration of HCl? So the concentration is mole per liter HCl, or capital M HCl, or molar HCl. All those units of the molarity. So that's the same thing. So that's we don't know. Equal to. You start whatever is given to you, which is the 0.45, correct, mole per liter sodium hydroxide. Sodium hydroxide. Step number 1. This is step number 1. Step 2. Can I take the balance equation here out? I'm taking this one out so you can. Step 2 here. I have to get rid of the liter of sodium hydroxide. I have 83, correct? Divided by into liters, 0.083 liter of sodium hydroxide. Liter sodium hydroxide, liter calcium hydroxide cancels out. That's the second one. Step 1. Step 2. Now step 3 here. This is step 3. I have to get rid of moles of sodium hydroxide. I'm looking for mole HCl. So I'll put mole HCl in the top. That's what I'm looking for. HCl to mole of sodium hydroxide. This step here from chemical equation. So chemical balance chemical equation, the top. So 1 to 1 mole ratio. So the mole sodium hydroxide would cancel with the moles of sodium hydroxide here. Then I have the moles here, as I said. I have the moles. Missing for me the 4th step, which is the liter, mole per liter. So I have 1 here. And how many liters had taken? Taken this, which is 0.235 liter HCl. This is liter HCl. So 4 steps. Step 4. Divide by the liter. So then I have here, guys, mole per liter. Okay, so how does it look like? It looks like this, 0.45 over 1, 0.083 over 1, 1 over 1, and then you have 1 over 0.235. Okay, guys, that's the answer here. Okay, so you multiply those two, divided by this then, by this one. So how much is it? And you have to watch for the sig fix we are looking for. And we have 3 sig fix here, 3 sig fix, correct? We have here 2 sig fix, we have here 2 sig fix. Don't worry about absolute value. This is absolute value. So the answer has to be 2 sig fix. So how much is it? 0.16 capital M, 0.6 mole per liter, 0.16 molar. Okay, guys, that's the titration here. That's the titration. Okay, yes. What's that? Why? Step 2, you multiply it by the volume of sodium hydroxide, the liter of sodium hydroxide. So you cancel from the molarity of sodium hydroxide, small per liter sodium hydroxide. So the molarity of sodium hydroxide has liter at the bottom. So you have to multiply it by the designated amount used to reach the endpoint, which is 83 milliliters converted into liters, 0.083 liter, which is 1, nothing there, is 1, nothing there. You just multiply the molarity by the volume, give you a number of moles. And then you go for the equation, step 3. You look at your equation, what's the moles of the acid to moles of the base, moles of the unknown concentration, which is the acid is the unknown. The known is sodium hydroxide. You cancel the moles of sodium hydroxide, and then you divide the whole thing by the liters of HCl. Yes, but I will not recommend it. In the lab, it's okay. You see 1v1. That's the dilution law. If you look number two will be different. Let me just you mentioned that, and I want to show you it is not straightforward when you do this. Here, guys. Look, guys. This equation here, and I'll just here. If we can't finish on time, I'll stop whatever we have here and then upload it, and then at home, then I'll finish up the rest. So anyway, so edit, copy, and now I'm going to just show you that's not the case if you do the lecture, depending what you have. Now here, first of all, we say the equation. So let's put the equation together. So I have sodium hydroxide plus H2SO4, sulfuric acid, and they will give you sodium sulfate plus H2O. Now you have sodium, so you have 2 here, correct? 2 sodium, 2 sodium sulfate, you have 4, this is 2. So 1, 2 to 1 to 1 to 2. So you have 2 to 1, so 2 to 1 to 1 to 2. Now, if you want, what's the concentration of sulfuric acid? So mole per liter H2SO4. Let's do it together. Now, what's the first step we say? What's the first step? The molarity of sodium hydroxide is known because it's given to us its molarity and its volume used to reach the endpoint. So 0.75 mole of sodium hydroxide per liter sodium hydroxide. That's the first step. That's given. Then you have 38. You have to convert it to 0.038 liter sodium hydroxide. Why I put this one in the top? This one 1. Because this liter here at the bottom here, this liter at the bottom here, has to cancel this liter at the bottom here. Correct? This liter has to cancel those liter here at the bottom. Correct? Then the next step here, and that's what I just mentioned to you here, you have to watch. Here it is, guys. The mole ratio is 2 to 1. So I have 1 mole of H2SO4 to 2 mole of sodium hydroxide, correct? So sodium hydroxide then, sodium moles, so moles cancels out. I have mole here, correct? Then I have to have, the fourth is the liters, okay? Liters of H2O4 is this one here, converted will be not this is the bottom, mole per liter, correct? Okay, here it is. 1 over, oops. Okay, so next one is 1, and the liters are 0.155 liter H2SO4. So now you have the units left only mole per liter. That's the molarity. So now if you look at the whole thing here, that will give you the answer. Now, I use only C1 equal V1 if 1-to-1 more ratio, but this is 1-to-2. So the dilution law will never be done, will be never valid. Are you following me here? You have to put the balanced chemical equation first. If you have it, then you have to put the ratio between the acid and the base. There we have 1-to-1, straightforward. So 1-to-1 more ratio between the acid and base, you can use the dilution law. But then if you have the different from this, in this case here you have acid is 1, the base is 2. So then this one will not work. This one will never work. C1 V1 or C2 V2 will never work. You have to put it this way. Okay, guys? So this is the molarity of sodium hydroxide. This is multiply the second step, multiply by its volume. Third step, you have to watch for the chemical equation. What's the ratio? The mole ratio after balancing it. And then you divide it by the liters of H2. Are you following me here? So I'm not interested to get the end value, but this is show you dilution law if the mole ratio of the acid to the base are 1-to-1. If the ratio is not 1-to-1, you have to do these 4 steps. So why you bother yourself with the dilution law? You can do it from the beginning of 4 steps, and that's easier. So you keep track on the units and everything there. So that's the way it is. So well, I did not put for you. I think. Titration here, yes, we can do C1 V1 equals C2 V2 because the ratio is 1, so we can do a 0.45 molar of sodium hydroxide. You just make sodium hydroxide here, multiply by its volume, equal to, that's the molarity you don't know, question mark, and this is 235 ml. This is HCl. Solve for the M or the C or C. Sometimes they put C. C means concentration, M molarity. They are the same thing. You can say C1 V1, C2 V2, or some textbooks M1 V1, M2 V2. C is concentration and M is molarity, which is synonyms. Those are two words are synonyms. But anyway, so yes. No. Sorry, I said I'm not interested. Are you interested to have it? I can put it back for you. No, we can. It's no problem. I think it's still here, correct? Is it? Okay, no problem. I can do it. It's very quick. So we have the step. Let's do it from here. Step is the molarity of H2SO4. That's we don't know. So we start with 0.75 mole sodium hydroxide per liter sodium hydroxide. Then you multiply it by the liters of sodium hydroxide to get rid of the liter sodium hydroxide. Then the molarity is you have 1 mole of H2SO4 according to the balance to 2 mole of sodium hydroxide. And the equation here is 2 sodium hydroxide to 1 H2SO4 will give me 2 SO4 plus H2O, correct? 2. So then we have 1 over 0.155 liter H2SO4. Now, if I look at this, moles sodium hydroxide with more sodium cancels out. Liter sodium hydroxide, liter sodium cancels out. The only unit left is mole per liter. Oops, sorry. Per liter. Per liter here. Okay, so then you have 0.75 multiplied by 0.038 multiplied by 1 and divided by 1 over 1, 2, and 0.155. Okay, and this one is mole and this one is liter. So how much is it? We have to have two sig figs, correct? We have to have two sig figs. So how much is it? Somebody has it? 0.0922. One nine, yeah, 19. That's two, because we need two sig figs. Molarity, or 0.092 mole per liter, or 0.092 molar. So it's the crucial is 2 here. You cannot put C1 V1 equals C2. So you have to avoid this, because not all the acids and bases they have the same mole ratio. Okay, guys. So then we are. Let me see. Everybody has this. Okay, so what's that? No, I will raise it. Don't worry. Yeah, I'll raise it. Don't worry. I can delete this one here as well. Here. Hold on. Okay, so we are in the pH titration. Mass to the volume. Mass of the volume. Well, here it is. The answers are here, and we have 45 minutes. I think we'll finish it on time, so we have just few left. So I put something like this. I put some mass over the volume, and pick up one of them and let me know which one you like. 1 to 3. I want 3. I want to put 3, but I did not put. But 3 can be in the SAS exam, in the lecture. But I'm picking 3 for myself to review. You pick 1 or 2, and then we'll pick 3. 1 or 2, one of them, and then we'll pick 3. Which one you like? 3? No, 3. That's my choice. Your choice is one of those 2. So we'll do 2 of them. One of your choice between 1 and 2, and then we'll put 3. Which one? Number 2. Okay, let's take number 2. Let's take number 2. So here it is, guys. So, is this coming? Yes, I put similar to this in the final exam, because that will come. Now, in the ACS exam, it might be number 3 will come. That's my choice. That's the lecture choice. So, here it is. Here it is, guys. We are looking at mass over volume percentage. That's the unit here. Mass. And this is gram per mil percentage. You have to watch for this. So I have the grams is 67 grams. So guys, can I use 1.2 liter? What's the unit is? Milliliter. You have to watch for the units. So watch for the units. So 1.2 liter, and then you multiply it by 1,000. So 1 liter is 1,000 milliliters. So 10 plus 3, the opposite of that. So this one here will be 67, 1.2 multiplied by 1000 milliliter. And this is gram. This is mass, milliliter, volume, and the whole to multiply by 100%. So if you have done it correct, you have to have 2 sig figs, all over 2 sig figs. So you have to have 2 sig figs. And the answer here is 5.6. I'm not sure if that's correct answer or not. You tell me. The answer is correct? Somebody said yes. How about the rest? How about the rest? Yes? Yes, so I have more than one saying that's the answer here. Okay, so that's your choice. Now I'll take my choice, number 3, which is a little bit more, not tricky, but more demanding in the way you have to watch to work it out the other way. So let's take this one out. You have it. Everybody has it. So everybody has it. Okay, let's take it out. And I'm taking this one here as well out. And going to the mass of the volume, number 3. Number 3. Maybe you solve it here direct inside. So we'll solve it inside. We'll not even copy and paste. Not worry about it. So now you have to watch. The percentage is given to you, 40, yeah? Correct? Percentage is given to you. And the percentage is mass over the volume multiplied by 100%. So this is, the 40 is the mass is 70 grams, correct? And the milliliter, what's the volume? Milliliter you don't know, correct? And the whole thing multiplied by 100. You see that the trick here is, it is, let me see here, question mark, ml. So you don't know what the ml is. So I will just work it out. I will say, well, 40 here over 100. I'm pushing the 100 down here underneath will be 70 grams over ml. Then I do cross multiply. So the ml here will be, somebody will help me here a little bit, 70 grams multiplied by 100 divided by 40. Correct? And remember, when I say 40, this is gram per ml, as 40 is gram per ml. The ml will go up, okay? Because this is gram per ml. It is. So, gram with gram cancels out, the ml will come up. So how much is it? 70 multiplied by 100 divided by 40, how much is it? Here it said 175 ml. Now looking at the question here, is this the correct answer? No, why not? The sig fix is not correct. The answer is correct, but the sig fix is not correct. All those are one sig fix, no decimal, correct? Especially this one here. That's absolute value, percentage is absolute value. But 70 grams, no decimal, that's one sig fix. How in the world I can make out of this one sig fix? 200, that's when you go up. But I want this scientific notation without changing the number, a real number. That's with the going up or going down. I tell students don't do it. This is just very crude estimation. But I want to use this value and make it what? So I have 3 digits here, correct? So I make the decimal here going here will be 1.75. I went to the left. That's 10 plus 3. Correct? ml. Now I want to make, this is 3 sig fix. So 0.1, let's make it in red here maybe. This is 0.175. 10 plus 3 ml. So this is 3 sig figs. I want to make it now 1. Will be what? 0.2 10 plus 3 ml. This is the correct answer. This is the correct answer. Okay, which is your answer. Is it 200 correct? Did you say? You said you go up with the estimation 200. This time is correct, but not every time is correct when you go up. Some textbook they will tell you this is well, if that's 2 sig, it will be 180, but this is 1 sig fix. So it's better to go through the scientific notation, and then from there, you go whether to the left, plus exponent, or to the right, negative. Exponent is negative. So that's the correct answer. Not this. This is not, is according to calculations correct, but according to sig fix, is not correct. No, it does not. It does not matter. So you have this. So 3.8, 10 minus 3. That's still a scientific notation. But that's the correct answer. Main thing is the correct answer. Yeah. So can I take it out? Take it out? Okay. So now we had mass over the buffer solution. Well, the buffer solution. Now I have the buffer solutions are solution made of weak acid with its conjugated base, or weak base with its conjugated acid. So buffers, let's write here. Let's write here. Buffers are solutions made of weak acids plus their conjugated or conjugate bases, or weak base or bases plus conjugate acids. So acids here. So that's the buffer. Now, if I give you in the exam something like a bear, so the acid, what is the acid? What's the base? So let's look at the definition here. So we'll have 3 of those here. Where's the buffer here? Can I take this one here out first? So you have this. Everybody has this. Okay. So let me take this one here out, and then come up with the buffer solution. I'm taking those three acids. Okay. So those are 3 acids, and you tell me how to do to make those acids, the buffer out of these acids here. So we have acids, correct? I can take the bases. So those are 3 acids, copy, and I'm just putting them here. So I want to make acid. So the acid here first, the acetic acid, the first one here. See, this is 1, 2, 3. Correct? So 1 acetic acid is looking like this. When you dissolve it in H2O, you'll get something looking like CH3, COO minus, and it's always donating. Acid donates its proton, so plus H3O plus. So this is an acid. This is a base. Well, a conjugated acid, this is conjugate acid, and this is conjugate conjugate base. So what is really this? It turns out to be, that's what we discussed in the lecture. A conjugate acid is actually, it was a base. It was a base that accepts protons, correct? It was a base that accepts protons. And the conjugated base, it was actually this is conjugated acid here, conjugate base, is actually it was a acid that lost the proton. See here? What do you mean? Yes, yes. Well, the protons here is the proton is here is H plus, correct? So then where it's valence electron, it lost its valence electrons already, correct? So here it is. You have conjugate acid, conjugate base. The buffer will be made of acetic acid and its conjugated base, which is COO minus. This is a buffer. Phosphoric acid, H3PO4, and take one protons out, H2, correct? PO4. See, will be last one. One hydrogen is out. When you lose one hydrogen, one negative. You lose two hydrogens, two negatives. Now, hypochlorous acid. Hypochlorous acid. What's the formula of hypochlorous acid? That's not covered, but it's an opportunity to review the lecture, correct? Let me show you what those acids is coming from. So, can I take this one out? Everybody has it? So, those two straightforward. Phosphoric acid is this. Take one less, minus H plus, will give you this one with the negative here. Minus H plus will give you this one here with the negative here. Correct? So those are buffers. Those are buffers, correct? If you get the question, what are those buffer or not, you can be able to tell. Okay, so losing, the acid will lose, and the base will gain. So here it is. Let me take this one out. Now let's look at phosphorus acid, and I can remind you with this. And we have, this is my standard one, and my standard one is this one here. Then I can go here. I can go here. If I have, theoretically, it's not really present, but I can theoretically have something looking like this. So you will see the standard one is ic acid, no problems, so correct? No prefixes, no nothing. So this is chloric acid, correct? Less oxygen will be chlorous acid. Remember this ic acid. So here it is. Ic acid, here os acid. The last one here, oxyless will be hypochlorous acid, correct? So you can see it has two. Hypo means less, and then the chlorous acid, which is coming from less than the other one. Okay. Now, if you go higher than this, then you have it's hyper, but they think that there's just per and then chloric acid. So, ic acid, here it is. Ber, and then you have here ic acid. Okay, so now here will be, this one will be phosphoric ic acid. And this one here will be what? Somebody will tell me? The same thing. Phosphorus acid. This one will be hypophosphorus acid. Those are found in we can produce them in the lab. This one here, I have a question. I've never seen it. It will be a super acid then. I mean, it's a weak acid, but I have not seen it. It might be there. So there will be what? Phosphoric acid. The phosphoric acid is always one oxygen more than the standard. This is 4, 1 is more. Less will be acid. Ic acid, that's the standard. Less than the acid will introduce hypo. More than the standard, ber or hyper. Ber phosphoric acid. So now we know hypochlorous acid, it is what? Is this one here, correct? This is hypophosphorus acid. This is a weak acid. And what will be its conjugated base? So I have a combination of H3BO2, that's an acid, weak acid. What will be? Remember, minus will be what? H2BO2, 1 negative, because you took 1 proton, that will be H2BO2, 1 negative. Correct, guys? So this here will be, this one here will be H3BO2, that's the acid, and the conjugated base will be H2BO2, negative 1, negative here. Okay, guys? So that will cover the whole thing here, the buffer. So then we'll go for Le Chatelier and the Moore ratio. The Moore ratio and the equation. So I'm taking this one out. As I said, you can look into this, and then again, this is not coming. This topic is not coming in the lab. It will come in the lecture. I don't know, but I have never seen it in the lecture for a while. Maybe higher chemistry, yes. Principles or organic, they might bring something like this. So I'm taking this one out, and then take this one here as well out, and then we cover the Le Chatelier principle. Le Chatelier principle is here, and this is Le Chatelier principle. So let's look at this one here, and I would like to see if we can have all those gases here. That's good, but I want to see if we have a liquid somehow, or solid. We can see. I'll come with something, and then I'll tell you what's. So let's choose for me here this system here. Maybe this here. Hold on. We'll take this one here. Okay. Okay, guys, and I want to see what will happen if we have increase. Maybe we have something here. Yes, let's do this one here. Let's do this one here. Don't worry about this shift. We are looking at the shift where it will be shifting. Okay, let's take this one here, and let's take ammonia. We covered this one here. Let's take this one here. So we'll not do this Le Chatelier principle, and we have, this is a very good equation here, and we will do by arrow. So here is the key. Arrow means increase, up, down is decrease. That's the key here. L means the shift will be left. R means right. So if I add more H2O to this reaction, where will be the shift? As I said, we are not taking this, we are not taking this, we are not taking this. We want to see this one here. We're not taking this. So, and then we'll see how much is the whole, all of them, effect of forward reaction, effect of hydrogen. We can see how, all of them later on. So we are removing H2O. What will happen to the chemical equation? Where will be the shift? Where will be the shift? Right? Because H2O in the left. So when you add more H2O, we'll add this to the left. The left will be more stress, will be shift will be to the right. Okay, to the right. Now, when I say to the right, what will happen? And then I'll put here, instead of those here, I'll put amount of 1, 2, 3, 4. 1, 2, 3, 4. This is carbon. This is H2O. This is CO2, CO. This is hydrogen. So don't worry about whatever they say here. We'll take this one out. We'll see. So what will happen if you shift the whole thing? If you add H2O, you said the shift will be to the right, correct? If the shift to the right, what will happen to the product? Will increase or decrease? They have to increase, so they will go up, up, and those will go down. Will go down. The reactants will go down. Okay, guys. So if you remove carbon, correct? If you remove carbon, what will happen? The shift will be which way? To the left. To the left means the products will, the reactants will, and the products will decrease to the left, and the reactants will increase. What will happen if you remove CO2? Shift will be which way? Removing CO2, guys, CO. Let's see, CO. If you remove CO from the right, what will happen? Shift will be to the right. That's correct. Okay, shift will be to the right. What does mean to the right? Means those are up, products will be more, and the reactants will be less. Okay, so leave the volume by itself. Leave the volume by itself. Volume and pressure will come back to this. Leave this one here by themselves. We'll come back to them. Now, you are warming up. You are warming up. Where will be the shift? First of all, what type of reaction is this? Exo or endothermic? This is positive. This is endo, correct? That's endo. Positive. Endo is gaining heat. So now if I add heat from outside, so this one is written is here, but it should be written here, correct? Heat should be written here. That's the left. The left, that's endothermic. If you heat up, the shift will be which way? To the right. If you heat up, warm up, it will be to the right. So, oops, sorry, that's not the case here. This is for the volume. We'll come back to that. So shift to the right. When it's shift to the right, the products are up, up, the reactants down, down. If you add argon, do we have argon somewhere here? Non-applicable, no shift. It's like a catalyst. If you add a catalyst, argon, or add catalyst, has no effect. Because you have nothing there, argon. Do we have any argon here somewhere in the reactants product? No. Whether you add some inert stuff or add catalyst, they have no shift, non-applicable. So there's no influence on the chemical equilibrium. Now, half means decrease, correct? Half means decrease the volume. Okay. First of all, I want to see. I will add another column there at the bottom. So I will add. Hold on, guys. I want to add this one here. Just bear with me a little bit. Now add the pressure. Okay, so I'm taking the whatever is all there. I took the whole thing here. Now I have it is, guys. So now if half means volume, I will get it is. I will add decrease the volume. Decrease the volume here. Decrease the volume. Increase the volume. And then we'll see what will happen. What will happen if I increase the volume? What will happen if I increase the volume? Remember, the reaction is, just write the reaction here. The reaction is here. Carbon, solid, plus H2O gas, give you CO, gas, plus hydrogen gas. And plus heat is here. So, if you increase the volume, where will be the shift? Well, I can't do this unless I have to calculate the number of moles. Solids is not part of consideration. Solids are not part of consideration. I have 1 mole here. So this side here, the left side has 1 mole. This side is 1 plus 1 is 2. 2 moles. So it's decrease the volume, which is according to Boyle's gas law. Increase the pressure. When increase the pressure and decrease the volume, it will go to the side with the least number of moles. Correct? The least number of mole where? This is 0 mole. 0 mole. Because solid, it's not changing. Only gases, you consider gases. So 2 and 1 will be where the shift will be. Shift will be to the left. Left here. Increase the volume, meaning what? You decrease the pressure. So it will go to the side with most number of moles, which is in this case the 2. 2 is more, so will be to the right. R. Okay, guys? Everybody's following? Now the heat, we said we added, we warmed up, we added the heat here, correct? How about if I cool the system? What will happen? Where will be the shift? Here it is. Reaction is cooled down. So shift will be which way? Take it out from the left side, will be the shift will be correct to the left. And the product to the left means the reactants will increase, the product will be lower. Everybody is familiar with that? I want you to be familiar with this. This is not the lab question. This is lecture question. Are you following me here? This is not in the final, but it's good. Will be a review for both. Last topic here, and then I think we do have still time. Last topic is, can I take this one out? Take it out? Okay, so watch for this volume. Whenever you have solid inside the equation, don't consider it when you calculate the number of moles. So here it is. This one here, you have to watch for this solid here. It's not part of the calculation of number of moles, correct? Saying this, I would like to see if you can tell me, taking this one here out as well. Okay, so just to look at the one with the gases here, most gases. Add catalyst has no effect, correct? Here, just quick. Tell me where the shift will be. Just tell me what the shift. If I will increase the pressure, it is. Here, I want here in this reaction here, not the temperature. I want to do the pressure is very up, increase the pressure, which is in my other language of Boyle's gas law, decreasing. So where will be the shift? Increase the pressure, decreasing the volume. Where will be the shift? How many moles here we have? 4, correct? That's not part of it. How many here? 3. We'll go to the least number of moles. So it will go this way. Now, if I will say, just to review this one here for the lecture. If I will say this one is decrease, which corresponds to volume increase, to the most will be which way? 4 or 3 will be to the right. And this one here will be to the left. Correct, guys? Just to review for the lecture part of the whole thing here. So, last topic here is number of moles. That's not Avogadro's, that's lecture Avogadro's, but we need to know okay, something like this. How many grams of acetylene if 1.1 mole of CO2 are produced? Well, the equation is here, correct? And we want to see, first we'll do A and first we'll do B. We do have, the lab goes until 1:45, correct? I mean, 12:45. So we can do two of them and then we'll call it off, okay? Thank you very much for your patience here. So we have this chemical equation. And we want to see how many grams of H2O can form if you have 113 grams of acetylene. This is acetylene here. Okay, it's burned out. So, and the ratio, is it balanced or not balanced? Is it balanced or not balanced? It's not balanced. So, what I have to do? Balance it. So, what will be the balance? Here is 2. Correct? And the hydrogen is already 2. So you have 4, and then we have how many? Correct, guys? 2 and 2, 4, and the oxygen is 5 in the other side. This will be what? 5 over 2. Everybody agrees? 5. Then you multiply the whole thing by 2. The equation will be looking 2 C2 H2 plus 5 O2 plus 4 CO2 plus 2 H2O. It is balanced now. 10, 8 and 10, 4 hydrogen, 4 hydrogen, 2 carbons, 4 carbons. Yes, that's balanced now. Now, that's the first thing you have to do. Balance chemical equation. Balance the chemical equation. You have 100, you start with 113, always whatever given to you. Acetylene, I will say AST, acetylene. So what's the next step is? To get the grams out, correct? So the grams, I have to use the molar mass. I have to divide by the molar mass. Mole of acetylene, correct? So how many moles we have? 2 carbons. What's the molar mass of this? 2 multiplied by 12, 24, plus 2, 26. So 26.0 gram per mole acetylene. Now grams with the gram acetylene cancels out. The mole, and I need what? I need H2O. So I say mole of H2O to mole of acetylene. So from the equation, I have 2 moles of H2O to 2 moles of what? Acetylene. 2 to 2. Correct? Then the last step is the molar mass of H2O is 18. 1 oxygen is 16, 2 hydrogen, 16 plus 2, 18. I need the grams of H2O, so 18.0 gram H2O per mole H2O. So mole H2O with mole H2O cancels out. Mole acetylene with mole acetylene cancels out. And the answer is 113 over 1. 1 over 26.0, 2 over 2, and then 18 gram H2O. So how much is it? 113 multiplied by 2 multiplied by 18 divided by 26. How much is it? 12 point. We need 3 sig figs, I think. Yeah, 3 sig figs. 462. 12.5 gram H2O. Okay, guys, you want me to do for you the second one? How many grams of acetylene if 1.1 mole of CO2 are produced? Well, we can do that. Let's do it this. Let's have this one here. Everybody has it ready? So we have 2. Let me just write 2 to 5. And 4, 2. That's the mole ratio. Okay, guys. So let's do the second one. Can I take this one out? 2, 5, 4, 2. So here it is. So we said, remind me here again, the balance, 2, 4, correct? Or 2, 5, 4, correct? Is it? What was the ratio, guys? You have it. This is 2, 2, 5, 4, 2. So how many grams of acetylene react if you have 1.5 or mole of CO2? So you start whatever is given to you, mole of CO2. That's given to you, okay? And you need grams of acetylene. So you look at the moles of CO2 to acetylene. Here it is. So I have here from the equation mole of CO2, 4, and 2 mole of acetylene. So mole CO2 cancels out. And then I have to get rid of mole acetylene. It needs grams. Acetylene, that's 26, correct? Is it 26? 26.0 gram, this is 0 here, acetylene per mole acetylene. Mole acetylene equal to, so you have 1.10 over 1, 2 over 4, and then 26.0 over 1. And this is gram of acetylene. So the answer is how much is it? 28.6 gram. 3 sig figs. We need 3 sig figs. Don't worry about 2 to 4. 2 to 4, that's absolute ratio. Oh, okay. 14.3. Okay. Okay, so that's the whole thing is covered. I covered more than whatever is come. So if you review this, I can guarantee you with a very good outcome in your grade. But you have to review this, and if you have any question, just let me know. I'll stop recording. Thank you very much. Good luck for the final next week. Thank you.